Now we are going to solve the same exercise as in the previous exercise. We have to prove that this formula set is satisfiable. But now, before analyzing the value of formulas and variables, so before that, we are going to try to transform our formulas a little bit, just to make it easier to come up with a solution. So as you remember, we started with not P, and from this we derived that P must be false. And then we use this fact in the fourth formula. And this is the formula which I'm going to transform now. This is an implication, and I'm going to use a well-known logical law to transform this formula to another more convenient form. This logical law is called the contraposition. Sorry for my handwriting. Contraposition, which looks like that. If you have an implication A implies B, then this is equivalent with not B implies not A. So basically, you can flip the two sides of the implication and negate them at the same time. So this is why we can translate this R implies P to not P implies not R, which is cool because since we have not P here, so we know that P must be false. From this fact, we can imply to other facts like R must be false as well, right? It's negated. Okay, so let's do the same trick to this formula here. Let's apply contraposition. So let's flip the two sides of the implication and negate both sides. Exactly. Okay, so far, let me summarize what we know. We know that P must be false. Then, since P is false, then R must be false. And since R is false, Q must be false as well. I just rearrange my formulas now, and I will keep going here. Okay, so let's continue with the second formula, which is a disjunction. And now I'm going to transform this to an implication because implications are so intuitive, as you can see on the in the bottom of the screen. So there is a very cool logical law about rewriting implications. It looks like this. If I have an implication A implies B, then I can rewrite it to disjunction. So you replace implication with disjunction, and also you negate the left-hand side, only the left-hand side of the implication. So this is something we can now apply from right to left, because I have a disjunction Q or S, and this is what I can transform to implication by using this law from right to left. Yeah, so long story short, this is what I get. Not Q implies, let me use white color just to be consistent. Not Q implies S, right? So this is what I'm going to put here. So since I already know that Q must be false, S must be true. This is a very nice chain of deduction here at the bottom. Okay, now it's time to deal with the largest formula here. Okay, something like that. And here the first part is completely all right because I know that S must be true, so I'm implying from this fact to another fact. But let me transform the implication in the parentheses a bit by using contraposition again. So I flip the two sides and negate them. So I get not P implies not T, right? Let me just copy this formula here. S implies not P implies not T. Yeah, okay, sorry, I cannot draw a parenthesis anymore. Okay, so now it's time to summarize. Let's execute this chain of deductions. So P must be false because of the first formula. R must be false. Q must be false. S must be 1. And finally, since S is 1 and P is false, T must be false. So these are the assigned values. These are the values must be assigned to the variables to satisfy all the 5 original formulas.